Okay, so for this, we're going to find the function's average rate of change. Now, we've done this, and I know you've done this a number of times, but I just want to remind you, average rate of change means you're finding the y value at 0, the y value at 2, and you are simply finding the slope of the secant line. Okay, the equation is f of, in this case, 2 minus f of 0 over 2 minus 0. Okay, change in y over change in x. Well, of course, f of 2 minus f of 0 is 2. Is 4. So 4 divided by 2. The average rate of change is 2. That's average rate of change. Okay. Now, average value from 0 to 2 is basically saying we want to find the area from 0 to 2. Okay, so we want to find this area. And then we want to figure out what height a rectangle would have to be to have the same base and the same area. Okay, I'm not guessing that's correct. I think it'll have to be a little bit higher than that to get what we want. But that's what the average value, from a geometry standpoint, that's what it does. It says, I want to find the height of the rectangle that has the same area as the function. So we need to find the area of the function. And then, just like any geometry, if you know the area of course is base multiplied by height for my rectangle, okay, for the rectangle. If I know the total area and I know the base, in this case, is 2, well, to find the height, I just divide by the base. So if you've ever if you've forgotten, well, why did we always have to do this thing in front? That's why. It's essentially just dividing by the base. So we can do the integral. I'm going to leave the 1/2 out front. Antiderivative would be 2x squared minus 1/3 x cubed, evaluated at 2 and 0. You plug in 2. We still have 1/2 here. Well, we plug in 2. We're going to get 8 minus 8/3, which is 16/3. We plug in 0, we get 0. So 1/2 of 16/3 is 8/3. So, it's under 3, so it's going to be somewhere up in here. So this would be the height of the rectangle that would give us the same area as the curve that has the same base. In this case, the average rate of change on the interval from 0 to 4, well, of course, you look at this. F of 4 minus f of 0 over 4 minus 0. Of course, that is, it is 0. And the average value, well, we would do 1 over 4 minus 0 multiplied by the integral from 0 to 4, and again we just have 4x minus x squared. Now, you can all calculate that, and I'm not going to do that for you on this video, but I did want to just mention this. Rate of change means derivative, right? So some people look right away and they say, well, f prime is equal to 4 minus 2x. And then they say, oh, but you know what? I'm not just finding the rate of change, I'm finding its average. So maybe I could do average value of the rate of change. Rate of change was 4 minus 2x. Well, I want you to think about this. The first thing you do is find the antiderivative, which would be 4x minus x squared. So back to the original function. Then you would plug in 4, and you'd plug in 0. So plug in 4 to the original, plug in 0 to the original, and then you divide by 4 minus 0. So there is this relationship, the average rate of change. You can find the rate of change equation and then do the average value. It's just more work. But hopefully it makes sense that they would be the same answer.